Hi, I'm Michael Ostroff and I'm a PhD physics student at FAU. So in previous videos, I talked a bit about my dimensional collapsar theory, and the topic of this video is going to be about like the metaphysics of dimensional collapsar theory. So this isn't actually important for actually understanding the theory. Like the theory itself is just only concerned about like a certain like mathematical reality and how it like evolves over like the coordinate space. But this is like a bit more broad, so I wouldn't say it's as important, but it's just like my own like thoughts on the metaphysics of it. Anyways, so you can have so there are these things called gauge fields. Like you can think of the electromagnetic for potential, and like there's, and using it and how it varies over like the coordinate space, you can get a electromagnetic field out of it, and you can observe this electromagnetic field. However, you can't observe this like electromagnetic for potential. That's not an observable that you have access to, but it is still there. An example of this is like the I'm gonna botch like one of the names, but Ahranov-Bohm effect. So these gauge fields, we can't really directly detect them, but we know that they're there. The reason we know that these gauge fields are actually fundamental is due to this thing called the Aharonov-Bohm effect. And essentially in this effect, you have this electromagnetic, you have this coil, essentially a solenoid, and there's an electric current going around the center of it, and there's a magnetic field in here, but there's no like magnetic field like over here on the outside. However, if you were to look at the electromagnetic for potential, the mathematics says that there would be like a field which goes around this like solenoid essentially, and there's a quantum experiment that you can do, which is this effect that I've mentioned, which involves electrons moving around this coil, this solenoid, and the regions that they're moving in, they don't have any electromagnetic field present really. It's only just the electromagnetic for potential. And if you were to expect the electromagnetic field, like the Faraday tensor, if like that was fundamental and not the electromagnetic for potential, you would expect there to be like you would expect the internal part of the solenoid where the magnetic field is present, but the particle never enters. You would expect that to have no effect on the experiment. However, we were able to actually detect how much magnetic flux is going through it based on the results of this experiment. You can look it up for more details. I'm a bit fuzzy on it, but essentially this shows that like these gauge fields are actually like a real physical thing. There just happens to be like infinitely many possible gauge fields, which all give the exact same observables, essentially. So I think of these, all these possible gauge fields, which give the exact same end result, as their own little mathematical realities. And if you were to perform like some gauge transformation, there'd be no like observables associated with it. But essentially, I think you're going from one mathematical reality to an entirely different mathematical reality. But because there's like no observables, no experiment that you could do even in theory, which could distinguish between them, these all correspond to the exact same physical reality. So you could have like, to say you had like, trillions of like different possible gauge fields which give the exact same reality would be a drastic understatement, but there would just be like that one physical reality in that one instance. So going back to that computational consciousness idea, where like you have a single like conscious computation which can be instantiated like several different times but only perceived once, you could have a bunch of like different mathematical realities in which a conscious observer is being instantiated in, and because they all correspond to the same like physical reality, these conscious computations which are occurring are the same, they're identical, and therefore they're only being perceived once. So like even though like if you were to like think about it in terms of mathematical realities, there's like infinite of you. If you look at the actual physical reality, your perception of like the world around you, that's like only perceived once. Like at least like with like the metaphysics of like DC, like my dimensional collapsar theory, and like the consciousness like ideas that I have. At least if you like put that together, that's like the result that you get. I believe I previously said something about how I found like some coordinate conditions in GR which allow general relativity to satisfy the zero curvature equation, which allows, which should mean that it should be able to be formulated as an integrable system. So I have a bit of a like conjecture. It's a very loose one because I don't fully understand how integrable systems work yet. But I suspect that like all integrable systems might be essentially a subset of general relativity, and that all mathematical realities have to be like, they have this like consistency criterion, and basically like they have to be so like mathematically consistent that they essentially must be integrable systems. And if you put both of those together, this means that all possible realities which like can have like observers, like mathematical realities, I guess, all of them essentially would have to be like general relativity, because like if I'm right that all mathematical realities have to be like integrable systems because of how consistent they are, and if I'm right that all integrable systems are essentially a subset of like just like general relativity, then that would essentially be the only like that would be like the end result. But because I don't really understand like integrable systems well enough, I can't really definitively say that. So just like a hunch I have, I suppose. I guess that's like my metaphysical views, essentially. Not important for like the actual theory itself, but like I guess if you're thinking about it, it might be I guess it's good for philosophers, I suppose, who want to like think about this stuff. But like for the actual calculations, it's not actually important. It's basically just like saying gauge transformations are a thing. So yeah. And also I would say that if you were to take any mathematical reality and you were to do like some coordinate transformation on it, then that would correspond to an entirely different mathematical reality, which is the same like physical reality. So anyways, like that's it for the video, I suppose. Feel free to follow my like Substack, or like follow my Substack blog, and subscribe to my YouTube channel, Perpetual Science. Have a good day.